Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through geometric proofs. So what is a proof in mathematics? Well, basically it's just a series of statements that leads you to a conclusion. So when we prove a result, what we do is we basically make an argument why something is or is not true. And if your proof is valid, no one will be able to argue with any of the statements, any of the steps in your proof. So we're going to start with some geometric proofs, and we'll prove that if a triangle has all equal sides, then each of its angles is 60 degrees. So one tool that's very useful for proving results in geometry is that of congruent triangles, with which you'd be familiar. So there are 4 tests for congruent triangles: SSS, SAS, AAS, and RHS. So remember that if you can use any of these 4 tests on a pair of triangles, they are congruent. That means pairs of corresponding sides are equal and pairs of corresponding angles are equal. So when constructing geometric proofs, if not given a diagram, it's sometimes very helpful to draw one, as I've done here. So these 2 triangles are clearly congruent by the SSS test. They have 1, 2, 3 pairs of corresponding equal sides. No one can argue with that. Now we know if 2 triangles are congruent, pairs of corresponding angles are equal. So that means that these 2 angles must be equal, these 2 angles must be equal, and so too these angles must be equal. But what do we mean by corresponding angles? Well, we mean matching angles, and what we need to note here, these 2 are obviously corresponding, they're facing the side of the same length. But hang on a minute, this X faces the same side, same length side as this one here. Similarly, this angle here faces the same length side as does the X here. So what we must have is that all these angles are corresponding to each other. So the X, the arc, and the dot are all equal. So this statement says what I just said. Each angle inside the triangle must be equal. They're all equal to each other. So why does that mean they're 60 degrees? Well, obviously we know the angle sum of any triangle is 180. So if you have 3 equal angles and they add to 180, each of them must be 180 divided 3, which is 60. So we have proved what we set out to. We've come up with a set of arguments that argues for this point up here, and nobody will be able to argue against any of the statements made. All right, let's now look at a geometric proof involving circles. So circle theorems are often taught in high school, although they don't come up in maths a lot. Now, one of the circle theorems is that the angle in a semicircle is 90 degrees. So if you're not given a diagram for these geometric proofs, let's draw one. So we're just going to start by drawing a circle here. Now, what we mean by angle in a semicircle, if this is a center, we divide it into a semicircle. It turns out if we make a triangle like this, the theorem says that this must be 90 degrees. So that's what we have to prove. So how are we going to do that? Well, just because I'm going to refer to certain angles, I'm going to call O the center of the circle, and I'll call this A, B, C. How am I going to prove that this angle here is 90 degrees? Well, proofs often require some ingenuity. And the ingenuity here, we're going to divide this into 2 triangles. So it turns out that this triangle and this triangle must be isosceles. Why is that? Because the radius of a circle is always equal no matter where you start on the circumference. So because this triangle here has 2 equal sides and this triangle here has 2 equal sides, they are isosceles. So it turns out that in any isosceles triangles, the base angles are always equal. And that statement can be easily proved using congruent triangles. So the base angles are these ones here. They're where the equal sides meet the non-equal side. So I can give these 2 the same name. I'll call these 2 alpha, and I'll call these two base angles beta. I'm using the same pronumeral for the angles because they must be equal because the triangle is isosceles. Now, there's no reason that alpha and beta need to be equal. We can't assume, for example, that they're 45 each or something like that. We just don't know. Okay then, so what about this angle here? So this angle here is angle AOB. Now, because the angles in any triangle add to 180 degrees, this angle will be 180 minus alpha, so it's going to be 180 minus 2 alpha. So I'm just going to give a reason for this. And similarly, this angle here, which is angle BOC, that will be 180 minus 2 beta. The reason, again, is the angle sum of a triangle, which I've written here. It applies to these two here. But notice that angle AOB, this one here, and this one here, these two angles are supplementary. They form a straight line, and so they must add to 180 degrees. So we can simplify this equation here. So what we can do is we can add 2 alpha and 2 beta to both sides. 180 plus 180 is 360. So 360 is 180 plus 2 alpha plus 2 beta. All I did to each side of the equation was add 2 alpha and 2 beta, and I also simplified that 180 plus 180 is 360. So subtracting 180 from both sides, I get 180 equals 2 alpha plus beta. So what I've done in this line, after subtracting 180, I factorized 2 alpha, 2 beta as this. If you expand this, you get that. Now I can simply divide each side here by 2, and I get alpha plus beta equals 180 divided 2, which is 90. And that proves what I wanted to do, because this angle here is alpha plus beta, and I just proved that alpha plus beta was 90 degrees. So I've proved that the angle here must be 90 degrees. The angle in a semicircle is 90. All right, let's now look at a harder proof. So we're going to prove that this gives the area of a regular hexagon. Now, since we're not given a diagram, let's draw one. So a hexagon has 6 sides, and regular means that not only each of its sides, but each of its interior angles, these ones here, must be equal. So I'm going to let S be the side length. So how could we find the area of this shape? What we could do is we could divide it into 6 triangles, and they're all supposed to meet in the center. Never mind my crappy drawing. Now the thing is that each of these triangles here must be congruent. The reason is that the diameter or radius of a regular shape is going to be constant. It's going to be the same distance from here to the center as it is from here to the center. So what that means is that each of these lengths here must be equal. Each of the blue lines, 1, 2, 3, 4, 5, 6, must be equal in length to each other. So each of these 6 triangles has 2 of the blue lines that are equal and 1 of the red lines that are equal. So they're all congruent by the SSS test. They all have the same set of side lengths. Now we know that if triangles are congruent, then corresponding angles are equal. So what that means is that each of these angles here must be equal to each other. So because each of these angles is equal, and because they're angles at a point, they form a full circle which is 360 degrees, the size of each of these angles is 60 degrees. So what we have here is we have a bunch of triangles, these two sides being equal, this being S, and this angle here is 60 degrees. Now, we spoke about this earlier, that you can easily prove that in an isosceles triangle, each of the base angles must be equal. So these two angles must be equal. But because the angle sum of a triangle is always 180, we must have that alpha plus 60 is 180. Now you can easily solve this equation. You subtract 60 and divide by 2, you actually also get alpha equals 60. Now if each of the angles is equal to 60 degrees, the triangle is equilateral. So each of these 6 triangles here is an equilateral triangle. That means that if S is its base, these 2 sides are also S. So we can find the area of this triangle using either Heron's rule, base times height over 2. They're fine. It's probably easiest to use half AB sine C. And the reason is we know the exact value of sine 60. So what we have is the area of each of the triangles is going to be half times S times sine 60, and remember sine 60 degrees is root 3 on 2. So a half times root 3 on 2 is equal to root 3 on 4. So each triangle has area of root 3 on 4 s squared. Therefore the area of the whole shape, well, there are 6 such triangles. So it's 6 times root 3 on 4 s squared. So we can just simply simplify 6 over 4, and you can divide top and bottom by 2, and you get exactly what we were asked to do, 3 root 3 on 2s squared. So sometimes proving things like in this case the formula allows us to understand why the formula works, get a really good deep understanding of what's going on. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.